get really mad if he doesn't.
I won't play on
No. Sitting there. If I'm gonna do all the stuff to put it on YouTube, upload it to my classroom, I better watch. I better see one view at least. All right. When we're using factoring to solve, we're really using something called the zero product property. And this gets down to, do you understand what happens when you multiply by 0? What happens when you multiply by 0? You could have, it's just 0, yeah. You could have 0 times 15 other things. If it's all multiplication, the answer is 0, okay? So if we can get something to look like this, so we're going to focus mostly on two kinds of factoring. One is binomial factoring, looks like this, and then we'll pull out a common factor sometimes. If we can get something to look like this, and this is a product because I'm multiplying those two things together, what that means is then we know one of those two things, but we're going to say we have to treat that each of them could be 0. So either x minus m could be 0, and in that case I would solve the resulting equation, so I'd add m to both sides. So this would be x equals m, or x minus n equals 0, meaning x would equal n. Okay. Going back to Algebra 1, the significance of this is on a graph is these are the zeros on a graph are also called the x-intercepts. And so sometimes I might say to you, solve by finding the x-intercepts. And that's just a fancy way of saying, hey, we're going to find the zeros by factoring. Okay. So let's do that for an example and show how it works. All right. Let's solve 2x squared minus 3x minus 2 equals 0. Oh, this is makes me mad. New pen. Where's my other good black pen? Okay, I'm going to change colors. All right, by finding x-intercepts. Sorry about that. That is a nice pen. That's a nice color. But I liked... Now I had to change the color right in the middle of an example. All right. Gosh, if you need to brush up on factoring, I would just probably find either a Khan Academy or some kind of video. But if you had me for Algebra 1, did I have any? Oh, yeah. Sometimes I would use a box with this, if you want to use box method. But really, I just kind of teach, have a pencil and an eraser method. If it doesn't work, then you got to try something else. All right, so I'm going to put my two parentheses. The understanding, you got to understand FOIL. That first, outside, inside, last gets me this. So when I'm reversing that process, I have to think, okay, I know the first things have to multiply to be 2x squared. There's only two choices for that. So that's got to be a 2x and an x. Okay. Now, the last thing has to multiply to be negative 2. And so we know that one has to be positive, one has to be negative, and it has to be 1 and 2, right? But you have to be careful, because when you're doing like, how do I pick? When you're doing your outsides and your insides, those are like terms, they have to add up to -3. So you kind of got to think ahead, where would those things go so that the outsides and the insides add up to -3. Okay, I'm thinking I'm going to put the -2 here because that gives me a -4x. And I'm going to put a +1 here because that gives me a 1x. And doesn't -4x plus 1x add up to be -3x, that middle term? Okay. Now, you might have to have a pencil and erase things and play around with it. That's where it comes from. All right, now I'm not done. I have to solve it. So these two things multiply to be 0, so I set each of them equal to 0. So I have 2x plus 1 equals 0. Subtract 1. Divide by 2. X equals -1/2. That's one of my answers. And then x minus 2 equals 0. X equals 2. All right, now, sometimes I'm going to give you something that's quadratic, and you could multiply it out and factor it, but I'm going to show you a kind of a easier way to solve it. So if I asked you to solve this, 2x minus 1 squared equals 9. What you could do is you could do 2x minus 1 times 2x minus 1, multiply it out, and you could move the 9 over, and then you could probably factor it and it would work. But if it's already grouped together, see how these ones were separate so I couldn't write it as a squared? If it's already grouped like this together, you can actually solve this by using square roots, okay? Because this is written as a product of the binomial squared. So the way I would solve this is I would actually take the square root of both sides. Okay, don't forget there are two numbers that when you square them they give you 9. One of them is 3, the other one is -3. Okay, so when I take the square root of both sides, I have to remember I'm going to add a plus or minus to the front of that. So that undoes the square. I have 2x minus 1 equals 3 and 2x minus 1 equals -3. Would you solve those two, please? That's what I got. I like putting boxes around things and highlighting. That doesn't. Sometimes I do like circles. Doesn't make it any better. I guess because I think I do that because there's a lot of work, and then it's like, okay, that highlights what the final answer is. So, all right, cool. Hey, by the way, hold on a second. You don't have to write this down. I'm just writing this down. What if you saw like something like this? You could solve that by using square roots, but you'd have to do something first. Anybody know what it is? Yes. That's a 5. Sorry, it sometimes looks like an S. Now, this one wouldn't be a super nice answer, which is fine. You would just have to use your calculator to approximate it, but you could still use square roots to solve it. All right, cool. Last, what you've all been waiting for. The last algebraic way we're going to talk about today is the quadratic formula. You're going to need a new page, sister. Nope. All right. Okay, so first of all, to use the quadratic formula, your quadratic form has to be in a certain form. And so you have to have your x squared term listed first, then your x term. By the way, if there's no x term, then you could still use quad formula. It's just that b would be 0. And then we have a constant equals 0. So there has to be a 0 over here to use quadratic formula. If there's not, you're going to move it. And I'm going to have you do one where we move it in a sec. Okay, next. The quadratic formula is x equals the opposite of b. Now, in the song, I say negative b because it sounds better in a song than opposite. But really, this means it's not always negative. It's the opposite of what b is. So up here, if b is a positive number, this would be negative b. If b is a negative number, then that would be positive. Opposite of b, plus or minus. Square root b squared minus 4 times a times c. If you were Mrs. McDonald, she puts a and c in parentheses instead. It's not right or wrong. All over. Make sure it's all over. Some people try to put it right there. Whole thing. 2a. Does anyone want to sing the song? I'll sing it. And you can join along if you want. X equals negative. It's like the Pop Goes the Weasel song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I honestly sing, I still sing the song in my head, like when I remember it. That's how I remember it. So, all right, let's do one. Last example for today, then we're going to do some practicing. Let's solve 3x squared minus 6x equals 5. And we're going to use quadratic formula to do that. Okay, what do you notice? Not in the right form. Let's move that 5. So now we have 3x squared minus 6x minus 5 equals 0. Now I'm going to tell you how I would break it up. Because if there are nice square roots at some point, you might want to simplify them. Okay, so what I would do first when I plug it in is I do my setup. So we have x equals, opposite of b is positive 6, plus or minus, square root. This one I do put in parentheses. People are going to screw this up. Somebody's going to screw this up right now. Somebody in here will, I promise. It's okay. Because what happens when you square something? It should be positive. You don't type this in your calculator correctly. Wait, this one you should be able to do in your head. But if you have one and you don't type it in correctly, it's going to look like negative. And that's not the calculator's fault. That's your fault. Because some people type in this. And that is negative 36, because that means negative 6 times 6. That's negative 36. That's not what this is. You have to square the whole number. You need a parentheses. Or just do it in your head. The more we do in our head, probably the better. Okay. Minus 4 times a is 3, times c, which is negative 5, all over 2 times a. Okay, so I always do this part first. I figure out what's inside that square root. All right, so I know this is 36. This is minus a negative. Minus a negative means it's going to be positive. So let's see, this is 36 plus 60, which is 96. Okay. Do you want to see the exact way first? I got to think of perfect squares that go into 96. Can anybody think of any perfect squares that go into 96? 16. Okay, here's the deal. Could you just take the square root of that, approximate it? Yeah. Okay. I'll do that way first. What's the square root of 96 about? I get 9.8-ish. Confirm? Okay. Then we're going to do 6 plus 9.8. I encourage you to do this along with me. Hit the enter button, because otherwise you're going to just divide the last thing by 6. I get 2.63 for that answer. These are approximates. Then 6 minus 9.8. And then divide that answer by 6. I get negative 0.63-ish. I mean, those are... It says repeating, but it's really not because that's an approximate. Okay, confirm. Okay. Hold on. Or let me show you the simplifying square roots way. 96 is 16 times 6. 16 is a perfect square. I think that's the largest one that goes in. So what you could do is you could rewrite this as 16 times 6, because that's the same thing as that. And then you could pull out a perfect square and do it exactly. What I mean by that is this. What is the square root of 16? 4. So that could come out here. You can't divide those. That's a cringy math mistake. Because this is root 6 and that's 6. That's not the same thing. However, you could see that all 3 of these are even and divide them all by 2. So that would mean 3 plus or minus 2 root 6 over 3. You could do that. That would be the most exact way. This would be an approximate. I think your brain is full. All right, once you're done writing that down, we're going to